Hello all. Today I'll be talking about our paper Trust and Ethical Considerations in a Multi-Modal Explainable AI-Driven Chatbot Tutoring System. The case of collaboratively solving Rubik's Cube. This is the roadmap for today's presentation. I'll start by giving a background and the problem that we are trying to solve and the research challenges that we'll be addressing in this study along with the proposed solution to address these challenges. I'll also give illustrations to understand the concept more clearly, and I'll be concluding the presentation with a discussion, summary, and future work. Coming to the background, majority of the AI systems that are currently being used are black box, which makes it hard for the end users to interpret their outcome. In collaborative systems, the explicit instructive and productive form of collaboration, the positive feedback loop of humans learning from AI and AI learning from humans is blocked by this problem of black box. To the right side, you can see a figure in which explanations or communication of the explanations make the communication from AI to humans more clear, explainable, and this also makes the output of AI systems transparent. Explainable AI methods seek to allow information to flow from AI to humans more clearly. And this information needs to be protected from any form of leakage. Now, coming to the problem. In this study, our goal is to improve the AI-driven interactive multi-modal chatbot ALLURE, which was built to engage high school students to learn how to partner with the AI for collaboratively solving Rubik's Cube. Rubik's Cube is a puzzle in which we start with a shuffled configuration of the cube, and by rotating the faces, we get back to the original pattern with each side being a single color. Coming to the research challenges, since the target users for ALLURE are mostly children, it is critical to ensure that language in any modality, textual, audio, or visual, is acceptable both from the users and also the AI. And the system is able to steer conversations away from these dangerous situations. We also ensure that the system does not leak information about users from one group to another for the sake of privacy and security purposes. Here's an illustration showing how to solve a white cross on Rubik's Cube. From the precondition where the white-orange edge piece is not in place, we move the down face in anti-clockwise direction, front face again in anti-clockwise direction, right face in clockwise direction, front face in clockwise direction to eventually get to white cross. Now the edge piece is in place. Now I'll be talking about the proposed solution. In this figure, you can see the architecture of a general data-driven collaborative assistant and our specialized components. In the language understanding module, there is a language model that models a sequence of words as a Markov process. For example, this can be a spacey language model. And then there is a sentiment analyzer that analyzes the sentiment of the given input from the user, whether it is in the form of text, audio, or visual, and respond appropriately to the user message. Then there is also the intent classifier, which comprises of abusive language classifier and sensitive information classifier. Then we also have user models, word embeddings, and language lexicons, which can be used by the dialog manager to track the state and also generate the policy for responding. Dialog manager monitors the state of the dialogue and also generates the policy for responding to the user utterances appropriately. We also have information retriever that retrieves relevant information from the database and passes it to the DM whenever the user asks for any information that is not sensitive. And we have information source, which contains user information like their username, gender, score, games won, and also their skills. We also have game solver, which comprises of Rubik's solver and solution explainer. Rubik's solver uses users' current Rubik's Cube configuration to output solutions that will be passed to the solution explainer. Solution explainer will be trained on different states and different possible solutions given by Rubik's solver to give out a set of predicates which are nothing but Boolean functions that help determine state of the object and also aids in agents' decision making in the form of rules. The response generator generates the response based on the user query after going through this entire pipeline here. Here's an illustration which shows the sample interaction between a user and the Allure chatbot while trying to solve for a white cross with handling of information leakage and improper or abusive language. The user starts the conversation by asking Allure chatbot how to solve the white cross in a more inappropriate manner. Then the Allure chatbot warns the user by asking them not to use inappropriate language. The user decides to abuse the chatbot again. Then the Allure chatbot adds another additional layer of warning saying that I have been designed to ignore such inputs when repeated. Then the user asks the same question in a more appropriate manner. The chatbot then gives first step on how to solve for white cross and asks the user if they have any questions. The user again says that they did not understand a thing and abuses the chatbot. This time, the chatbot adds another warning layer on top of its original warning by saying that they'll also be reporting their interaction for potential further action. This scares the user and they immediately apologize. Now the chatbot goes ahead and finishes the tutorial. Then the user becomes curious and asks about their friend's performance. This time, Allure chatbot recognizes that the user is asking for sensitive information about different users, and it will say that this answer to this query will lead to release of private information of other users, so it won't be able to answer at this time. Then the user asks the summary of their own performance, for which the chatbot responds by giving their performance summary. Here's a working screenshot of our Allure after integrating the components that we proposed in the solution approach. By scanning this QR code, you will be redirected to our Allure chatbot demonstration, which can also be found at this link. Here are two methods that can be used to evaluate chatbots like Allure for trust. The first one is automated evaluation. Training and evaluation of hate speech and abusive classifiers in literature have been conducted on multiple open data corpuses. Testing Allure at the outset for it ensures that the system is more robust even before releasing it for field studies with user. The second category of evaluations is user evaluations, where we aim to transform learning experiences through a three-phase evaluation plan involving usability testing, pedagogical integration testing, and a large-scale evaluation with local high schools. Now I'll talk about important security concerns in chatbots like Allure. The first one is adversarial attacks. For example, this can be data poisoning attacks or backdoor attacks. Rigorous data cleaning and validation has to be done to prevent such attacks from happening. The second one is online learning. Currently, Allure does not use online learning but maintains a log of the conversation. In future, if the system were to use this history to personalize, then it could become susceptible to data leakage. The third one is protection of data flow. User would not be able to know if there is a man in the middle who is monitoring the user chatbot conversation. The data flow has to be made more robust in the backend to ensure safe communication that is free of such risks. Now coming to the conclusion and future work. In our paper, we described the trustworthy and ethical considerations in a multi-modal collaborative platform for helping high school students to collaborate with AI to solve a Rubik's Cube. We focused on especially two aspects of trust. The first one is acceptable conversations, which are free of any kind of abusive language, and information leakage. Our future work will be to use the evaluation strategies that we proposed to test the integrated Allure system with automated experimentation and by conducting detailed user studies. Thank you all for listening to this talk. If you have any questions, please feel free to reach out to me at this email.